All right, so what we got, guys, is going to be 10.6. So this is what we're going to be working on for the rest of the year, really. We're going to be doing probabilities from now until Wednesday. And then we'll have kind of a lab that should be on that Wednesday just to kind of get some of these concepts ironed out. We'll do the test on Thursday.
You don't have any next Thursday.
Yeah, right.
Oh,
It's 1 through 4. Wednesday.
you're right.
5, 7.
Okay. Then I'm going to retweak some things because, yeah, we'll retweak some things. And then we've got reviews after that. All right. So I will rework that because my throws off my pacing for the rest of this chapter. All right. So probability of simple events. Probability. Some of you guys have heard it before. What is probability? Fantastic. How likely something is to happen. Okay. And usually we can kind of break those things down into it's really likely to happen, or it's almost impossible to happen. Okay. We'll kind of talk some of this stuff out. Anybody watch Kentucky Derby over the weekend, or at least see some of the news on it? What happened? Like for the big race, there was this horse that had the worst probability ever, and it went through and won the race. So even though when we start saying it's unlikely to happen, there's still a chance. Okay? So, and then what we're going to do is we're going to be to find that where it says a complement of the event. So if we were to make this event bigger based on those same numbers we have, then we'll figure out what that probability stuff is. Okay, so for a simple event, and that's going to be kind of the first parts of the definitions we have. So the outcome's the result. A simple event is going to be one outcome, okay, over all of it. So out of the collection of all outcomes. So that's what a simple event is. It's going to be one specific outcome. And then the probability is the ratio as it compares the number of favorable outcomes to the number of possible outcomes. So out of all the things that could happen, how many times did it actually happen? And the thing that I want you to kind of focus on is going to be this formula right here. So it'll be written as P, which means it's the probability of something, with the favorable outcomes on top over all of them on the bottom. Don't worry about this rainbow chart. Okay? Good there? All right, so I'm going to start kind of talking some of this stuff first, this first example. It says a bag contains 7 pink, 2 white, and 6 blue marbles. Okay? And then we're going to start talking about drawing those out of the bag of marbles. Okay, so first thing we need to do is we need to figure out how many total marbles, how many total marbles are there? How could we figure out how many total marbles there are? Add them all together. So I've got 7 plus 2 plus 6. All of those together are going to equal 15. So on every single probability that we have, this number here, this 15, is going to be the bottom number. Okay, we'll still simplify the fractions, but this number here is always, always, always going to be our bottom number. So I'm going to look at that very first example. It says, find the P, or probability of blue. That's this P stands for. So what's the probability of you drawing a blue? You got that marble bag in front of you. You reach your hand in. You pull one thing out. How many total blue marbles are there in this thing? Yeah, there's 6 of them. So the favorable outcomes would be 6 on the top. My bottom number, always my bottom number is going to be this 15. So my simplified fractions I start with, or my simplified, my first probability is going to be 6 over 15. However, I do want to simplify that one down. Okay, they're both divisible by the number 3. So my probability for this is going to be 2 over 5. Thanks, sir. Mr. Rohr, in years past, did they do the percentage? Or they just Yeah, okay. What's that?
She did last year.
Did last year. Okay. So we got the simplified fraction. So we got 2 over 5. The very last thing we'll do, that's why I was double checking on here, is we're just going to write it as a percentage as well. So we'll take 2 divided by 5. So we'll take this fraction, and we're going to change this one into a percent. So 2 divided by 5 is going to be 0.4. And 0.4 as a percent would be 40%. These are the 2 things that I would like you to do. Where it says describe the likelihood of the event, don't worry about it. We're going to let the numbers do the talking. Okay? There's a 40% chance that we're going to get a blue. I'm good with that. We don't have to explain anything else beyond just the numbers. So far, okay? All right, we're going to look at this next one then. The probability of it being a white. How many white marbles are in that bag?
2.
Okay, so that's my top number. How many total marbles are in the bag?
15.
Perfect. Can I simplify that 2 over 15?
No.
I can't. That's as far simplified as I can do. Okay, so I've got 2 over 15. And then if I want to write this as a percent, I'm going to take 2 divided by 15. Let me grab my calculator. 13.3. Fantastic. So you should have got like 0.133. Move that decimal place over 2 spots. So my percent is going to be 13.3%. I do want both of those things, the probability as a fraction and then as a percentage. How you feeling so far? Okay, on to the next one. These are the ones where you're going to be helping or doing these things. This one says a box contains 8 red, 7 blue, and 5 yellow blocks. And we're going to select one without looking. So first thing I want to do is I want to find my bottom number for my fraction.
Add them all up.
Do it. You got 20? Anybody else do that on their calculator? Double check it.
20.
Did you actually do it, or are you just replying to what she said? Okay. Without saying it out loud, I want you to do this one on your own. I want to find the probability of yellow. You tell me the fraction, you tell me the percentage. So what we're going to do, see how you figure out where the bottom number was, because the bottom number makes sense. Okay, the top number of that fraction is going to be how many possible things could happen. So what's the 20 yellow blocks are in that entire group? Okay, so that'll be the number you're writing. Okay, it's always going to go with the bottom number. Okay, simplify the fraction. Well, if you get to the percentage, I still want to simplify it. The same number as one. What's that simplified? Oh, okay. Double check that. This is about how much white. Okay, so that's your simplified fraction. And then you just define those numbers you get as a percentage.
Yeah, I said you had that all that right. You just
one-
didn't simplify it. You want both.
Oh,
Alright. And you move that place over 2 spots. That's the percentage. So I've read it, so that way if you look at it again, just write underneath it 25%, that way you don't use that, those. Perfect. You don't have to worry about those, because I'm not worried about finding the red or the blue. We use all of those red, blue, and yellow. So they're on the bottom of Well, they check everybody else. We're good. Okay, so when you guys put this one together, when you guys put this together, you had 5 over 20. The one area where people were kind of forgetting about was making sure that this part got simplified. So we got to make sure that the top and the bottom both get divided by the same number. They're both divisible by 5. So my simplified fraction should be 1/4, and my percentage would be 25%. Okay? The reason we're simplifying that fraction down is eventually we're going to get to what's referred to as theoretical probabilities and experimental probabilities. That's what we'll talk about tomorrow. But I shouldn't have to reach in that bag 20 separate times to figure this stuff out. Here's where kind of that simplified fraction will go to. So we don't have to have such a big sample size. We can use that simplified fraction. Okay? All right. So the next thing I'm going to kind of show you is going to be this thing called a sample space, and we're going to get to a bigger sample space later. But a sample space is going to be something where we get to write out all the options of things that can happen. Okay? So this first one, we're going to talk about rolling a 6-sided number cube. In a fancy world, we call that a dice. Okay? But we're going to roll a dice. However, some people have played different games. There are more than just 6-sided dice. Okay, you can have like an 8-sided, you have a lot of sided dice. So we're going to roll a 6-sided dice, and then we're going to figure out all the ones that are even. Okay, so what we're going to do is we're going to, this first one's going to start off as a sample space, like kind of you only have one thing, but we're going to do something called a tree diagram eventually, which is going to have lots of other branches of things coming across. So if I'm going to start off with this number cube, okay, I'm going to make my little sample space over here. The things that it could end up as, if I roll that dice, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, those are the options that I have that it could possibly be. So this very first one, that's giving me my first little sample space that I can reference. This first one says, I want to know the probability of an even number. Or actually, before I get to the even number, how many total options are there? There's six options. I'm going to put the 6 on the bottom just so I don't forget about it. Now I'm going to look at my even numbers. 2 is even. 4 is even. 6 is even. I'm making little marks inside this space over here. That way I can look back at it to figure it out. So based on the little marks that I made on that in that sample space, how many total even numbers are there? 3. I went through and I made 3 different marks. So my probability is going to be 3 over 6. Is that fraction simplified? No. What could they both be divided by? Both by 3. If I do that, my simplified fraction is going to be 1 over 2. Or, and if I want to write that as a percentage, what's 1 over 2? Or 50%. So that's my probability of an even number. Okay, I'm going to go down to my next one then. I've got a probability of a 3, 4, 5, or 6. I'm going to make some notes. A 3, a 4, a 5, and a 6. How many total options do I have still? 6. I got 6 total options. How many favorable outcomes are there? 4. I've got 4 over 6. Can I simplify that fraction? Okay, by what? Simplified fraction, I get 2 over 3. Or 2 over 3 is a percentage? 66.7%. Because again, that last 6 going on forever, so make sure you round up. Because that 6 is higher than 5, so we're going to round up. So it's either going to be 2/3 or 66.7% of the time I could expect to get a 3, 4, 5, or 6. Okay? I'm going to use that same sample space up top. And you guys can try to use it. Ooh, it's about to die. It says, suppose number Q is rolled. Again, 1 through 6. I want you to find the probability of it landing on a 4 or a 5. Do that one in your paper. A 4 or a 5. We're going to do this one. We have the number Q rolled 1 through 6. So I still have that same sample space. I don't know if it's going to land on a 4 or a 5. Nope. It's just that number. It's just going to roll a 4 or 5. So either just this one or this one. Just one of those two numbers. Okay. It's only a 4 or a 5. So that would be just one number or just one number and 5. So how many would favor off?
Yeah, because if we can.
I've got a 4, so that's one outcome. I've got a 5, that's my second. So I have 2 chances to be correct. That would be my top number. And then my bottom's always going to stay the same. How many total sides of the dice are there? to simplify that fraction.
Just like small things.
Also, we should write it as a percentage.
Yeah.
Good. Awesome.
How many grapes have you got?
All right, so I'm going to use this exact same sample space. I'm going to write it for you, just kind of give us a chance to think about it again. Here. Okay, so again, I've got my 6 total options here. It said it wants me to have a 4 or a 5. So I'm going to make a little mark for the ones that it could be. It could be this one, or it could be this one. Okay, so if I look at this, the ones that I made marks on that show that it could be favorable, I made 2 marks. That'll be my top number. Okay, the total options, I'm going to count every single outcome that's here. I've got 1, 2, 3, 4, 5, 6. I've got 6 total outcomes that could happen. So my first fraction is going to be 2 over 6, because again, 2 is my favorable. 6 is my total. Okay, now I can simplify it. They're both divisible by 2. So my simplified fraction is going to be 1 over 3. Or as a percentage, it'll be 33.3%. All right? So that's going to be the probability of something. Okay? The next definition is going to be something called a complement. If it says complement, I'm going to write a real simple definition for you from the one that they give you. Okay? I'm going to write it this way. So the definition they gave you is that the complement of the set is all objects that do not belong to the given set. Before we were using all the favorable outcomes, the complement are all the not favorable outcomes. Okay, so whatever kind of that remainder would be. So if I looked at this one, my favorable outcomes would be 2. How many other options would there have been for this problem? How many not favorable options would there be? 4. I can just take this minus my favorable, so I got 4 over 6. That's where they get this complement part. Okay? So I'm going to go back to my very first example. I'm going to have this 7, 2, 6. Let me write it again. Okay? So I had 7, 2, and then 6. They were what? Pink, white, blue. So pink, white, and then blue. I can't spell. And then blue. So again, this was that one that we had 15 total outcomes. So that bottom part will not change. But if it says, I want to know the probability of not a blue. To get the probability of not a blue, I'm going to ignore this one and add up all the other numbers. So I got 7 plus 2. I'll write that in there. I've got 7 plus 2. 7 plus 2 is going to be 9. Over the same 15. Can I simplify that? Yeah? What are they both divisible by?
3.
Fantastic. I can divide them both by 3. And I get 3 over 5. My fraction's great. What's that as a percent? 60%. Okay. If I was looking at the ones that were not white, I'll do that one next. What would the top number be if I'm looking at not white? How much?
13.
13. How'd you get 13?
7 plus 6.
7 plus 6. Fantastic. Add those two together. You had 7 plus 6. So if I'm going to do the not white, you did 7 plus 6 over 15. So I still would have 13 over 15. That's already simplified by a fraction. What would the percentage be?
86.7.
How much?
86.7.
86.7%. Does that make sense on what I'm doing for the not favorable or the complement?
Yeah.
Okay, I want you to do 1, and then it'll be on to an assignment time. So this last one, it says, find the probability. We're rolling that number cube. We've got the numbers 1 through 6. I will make my sample space right there for you. I want you to find the probability of not 6. And Hector, you're going to pick that up. Yes, sir. How many of these numbers are not 6? So your bottom number, your top number is good. Your bottom number is going to be all the total choices still. So the bottom number is 6. So it can't be simplified. That's part of the Yeah, like I gave you all the options on there. Otherwise, you could just think of the number you could sell. Yes, sir. What is it, percentage?
Yeah.
That's not for the previous one. That's the 6. Perfect. All right, again, when you guys work through that one, you should have saw that there's 6 total options. The ones that were not 6, so I had this one, this one, this one, this one, and this one. So I had 5 that were not 6. So 5 out of 6, that's a simplified fraction. Or I could write it as 83%. All right. Again, it works kind of the same way for all these other ones. So I'm not going to kind of go too crazy on it. But what I want you to work on tonight, page 472, 12 through 28, even. When you are working on that problem, I'm going to let you know right now. They are giving you this dartboard. It's the same dartboard every single time. Okay? So the bottom number will be the same bottom number every single time. You'll still have to simplify it down, but I just want to know what the probabilities are for only that dartboard.